Hello. Hi. Hi there. Hello. Hi. We're doing. Hello everyone, welcome to Online Lab. Today you are joining me from the comfort of my back porch. It's probably like 40 degrees out right now, so just get ready for me to put on more clothes throughout the duration of this video. Super excited to see all of you, super happy to have you here for exercise
15.
My dudes. Wait, yeah, is that right? I think so. So excited to have you here for exercise
15.
This is my favorite lab, vision and endocrine system. Vision's super cool. That's actually what I spent most of my undergrad studying and researching, specifically retinal regeneration. Yeah, essentially, I'm just gonna kind of run through our lecture. I have my exercise right in front of me, and I'll just kind of make notes along the way. Heads up, I might not give like all the functions to everything, but I'm gonna be sure to show you everything where it's located. So let's just jump right into it, and we're gonna look at the eye. Alright, so we're gonna get into the eye. It looks a little overexposed on my monitor right now, but I'll make sure you guys see everything you need to find. So the very first thing we have is the palpebrae, and we also have the conjunctiva underneath it. So I'm just gonna kind of give you a quick run through on what those things are. So the palpebrae, your textbook and some other resources say it's like your eyelid. And then your conjunctiva. The conjunctiva is just a clear, oh crap, the lens fell off. The conjunctiva is just a clear coating over your whole eye. You actually have something called the palpebrae conjunctiva, which is actually the inner lining of the back of the eyelid. So it lines the back of the eyelid right here as well. That's called the palpebrae conjunctiva. So let's jump into our first thing. We're going to talk about how boogers are made, or lacrimal structures. So the first thing we're going to jump into is lacrimal glands. What are those? So looking at our eyelid here, we're going to look specifically at the top and on the back here. But what you have are, right here, is your lacrimal gland. And you can also see it from the back of the eyelid right here, lacrimal gland. And this is, we're looking at a right eye, so that would sit right here. Now what happens is your tears are made here in the lacrimal gland. Cool. Now what happens to those tears is that they move through these lacrimal ducts. You see these black dots right here? Those are your lacrimal ducts. So what happens is your tears are produced here, and then they go through these ducts. Now they're on top of your eye, and what happens is that you're going to blink, and as you blink, your eyelid is going to distribute those tears. And this is, the lacrimal gland isn't really making your crying tears, it's just like your general like buffers and tears to keep your eye moist. So what happens to those tears as you blink, you're going to re-moisten your eye. And what happens is that those tears will travel from here, diagonal over to here to where they'll be received. Now they're going to be received specifically at something called the lacrimal punctum. So this part of your eye right here, and zoomed in right here, we're going to see this punctum. The punctum are specifically this black dot there and this black dot up there. Now these are the openings that are going to receive all those glands, all the mucus, all that lacrimal gland gunk from the top of your eye that you moved over is going to be collected here. It's going to travel through the lacrimal canaliculus, which is this passageway and this passageway right here. Once those connect here, they're going to be collected in something called the lacrimal sac. So I'm going to put this back together for a second. The lacrimal sac. Now your lacrimal sac, so tears go from here, travel along here, collected there. The lacrimal sac is going to be this piece right here. That's where the canaliculus are going to travel into, and then from lacrimal sac, those tears and any of that gunk is going to go down into the nasolacrimal duct. From there into your nose, and now you have boogers. Yay! So essentially, yeah, just to sum that up, gland, ducts, punctum, sac, nasolacrimal duct. And that's just how you keep your eye moist, and that's how tears are collected from here all the way over here. And that's also why when you're like crying really ugly, you're just snotting and stuff, just because it's going through the nasolacrimal duct. Anywho, hopefully that's some fun biology for y'all. The next thing we have is the extrinsic eye muscles. So once again, we're looking at a right side eye. So first thing we have is the lateral rectus. So this is right side eye, your nose is right here, right along the side here. This is your lateral side, is going to be the lateral rectus. I'm going to come back to the medial rectus. I'm going to explain a few more things. Here's that palpebrae muscle again, but right underneath the palpebrae muscle, guess what? Your superior rectus. Guess what's opposite to that? I'm going to take apart the eye here. We just took off the superior and palpebrae. Down here, the very bottom, opposite to the superior rectus, is your inferior rectus. Now, this muscle up top here, if it's kind of hard to see from this. Oh, here it is. This isn't that bad of an angle. Kind of loops up and comes around here. It comes in at this oblique angle, so I wonder what this is going to be. It's also high up. So that's your superior oblique. Now, what we talked about last, or a second ago, was here's your inferior rectus down here. Well, if you look very carefully, you kind of have to angle it like this. You have this one muscle swooping down underneath, coming in from an oblique angle again. And that's your inferior oblique. And then your last muscle, all the way over here on the other side of the optic nerve, right next to your nose, that's your medial rectus. Hi everyone. So here we are on the fibrous tunic. The fibrous tunic is pretty much that general outer eye structure you're used to seeing, this right here. We're going to jump right into it. We talked about the conjunctiva, that clear membrane over the eye. Well, right underneath the conjunctiva, this white part of your eye is going to be the sclera. And the piece that covers your iris and your pupil, this clear piece right here, this is your cornea. So now we're going to talk about the vascular tunic, which is the part of the eye that's keeping nutrients to the eye, that's kind of keeping it functioning from an internal aspect. So I'm just going to disassemble the eye here again, take off the palpebrae and superior rectus, take off the lateral rectus. Now here we are with the eye. I'm just going to dissect the sclera really quick. Boom. Now we have the inner eye, this inner compartment right here. Looking into the vascular tunic, the first thing we have is the choroid. The choroid is this purple coating right here. Now normally this is going to be on the inside of one of the first layers after your sclera is going to be that choroid sitting right there in your eye. The choroid has a few neat functions that I want to mention. One is that it's highly vascularized, which you can kind of see right there. Additionally, some fun cocktail biology is, have you ever taken a photo with the flash on and you see like your eyes are red, or at night if you're ever driving and you see a cat and you see their eyes are blue, what you're looking at is actually light reflecting off the choroid or the choroid coat of the eye. One of the jobs of the choroid coat is to actually reflect light around and to keep light within the eye, so your retina is receiving more information and you're producing a higher quality, higher resolution image. Cool, so what we're going to do here is we're going to take this apart even more and we're going to look at the back of the anterior portion of the eye. Now what we're looking at right here inside here is we have a few things: the ciliary body, ciliary muscles, and ciliary processes. And I'm just going to kind of make sense of all that. So if you bear with me here, if you can see the white lines in this purple coat on the inside, those white lines in the purple coat, specifically right here, that's going to make up your ciliary body. Now, going into that even further, we have the ciliary muscles and the ciliary processes. The ciliary processes, I'm just going to jump and come back to the muscles, are these white lines right here. Now, the job of the ciliary processes is to actually make something called the aqueous humor, which we'll talk about a little bit more later, but it makes your aqueous humor. The ciliary muscles are going to be the purple right here and the purple in between the white right here. And the ciliary muscles, these are going to be the actual muscles that will change the shape of the lens, latch onto the lens, and control how you're going to be able to focus your images. So that's going to be right here in between the white lines, more or less. I mentioned real briefly that the white parts of ciliary processes produce the aqueous humor. And you can't see it on this model, but there's something called the non-pigmented parts of the ciliary body. So they're within the purple here as well, and they're going to produce something called your vitreous humor, which we'll touch on later, but I just want to say that right now. Moving on, we have our iris and our pupil. Now, the iris and the pupil are going to be these two parts right here. Your iris is the actual color part of your eye, and the pupil is the hole in the center of your eye that allows light in and out. The best thing to do when I talk about the iris and the pupil is I like to compare it to a camera and make the camera analogy. So right here I have one of my old cameras with me. I'm just going to take this lens off. Cool. So I took this lens off, and what you're looking at right in there, that little hexagon, really hard to see, that little hexagon inside there, that's your aperture, pretty much like the iris of the eye. And what happens is that the iris is going to allow in different amounts of light, and you can change how big and small it is. So here we make it bigger, so more light comes in, and we make it smaller, so less light comes in. Now, the significance of that for your iris right here, so in this case, the blue iris, whenever there's more light, it's going to shrink up and become smaller because you don't need that much light. But at night, for example, when it's dark, the iris is going to become super big, and your pupil, or the iris is going to open up really, really wide, and your pupil will become really big. If you ever like wake up in the middle of the night to like use the restroom or whatever, and go in the bathroom and turn on the light, and it's like super hard to see, that's because your iris is really wide open. And then if you like wait a few seconds, it just simply is going to constrict back down, closing and regulating the amount of light coming in. The inverse of that is when you then turn that light off, everything's super dark, but like in a minute or two, you're able to kind of see some things in the room. That's your iris slowly opening up, making that pupil bigger. But essentially, the pupil is the whole, the iris is the color. Awesome. We're now going to move on to the sensory tunic. The sensory tunic now, this is going to be referring to the most internal layer of your eye. We're going to be talking about your retina. So here we are again, just to kind of give some perspective because we take this whole thing apart. Your sclera, iris, your sclera, your iris, the choroid coat, and we look inside there. We have this pink coating on the back of your eye. This is your retina. This is where all your photosensors in your eye are going to be located. This is how you make images, and this is how you're watching this video. Kind of cool. So a few things to point out here. We don't really get into the rods and cones and how photosensors work necessarily right now, but we will come back to that later, but I'll give a little bit of information on that. So your retina is right here, made up of rods and cones as your photosensors. Rods are going to be light levels, cones are going to be color. I think, what is it, like males have less cones, that's why males have a higher chance of going colorblind, just genetics. So what we're going to talk about is the fovea centralis, the blind spot, and the optic nerve. So the fovea centralis, we're looking on the inside. This is the back of the eye right now. We're looking on the inside portion of it. The fovea centralis is going to be this 24, that yellow dot right back there. Now, what's interesting about the fovea centralis is that this is the point of your retina that has the highest and best resolution in the eye. The reason for that is because where it sits in the eye, so we have it right here, we can actually put this on. If you put on, when the eye is fully assembled, the fovea centralis, when light goes through the eye, the fovea centralis is the direct point right behind the pupil. So this is where the light's going to directly go right away. And this is whenever you're looking at something, whatever you're looking at and giving all your focus to, the reason why it's the most detailed image isn't just because you're focusing, but also because that light is directly hitting your fovea centralis. Now, the inverse of the fovea centralis is your blind spot. This is where you have no photosensors in your eye and you can't see anything. Your blind spot is going to be this white part back here. So once again, I'm still looking at the back of the eye. The reason that's your blind spot is because that's where the optic nerve feeds into the eye. So that's where you're getting vascularization coming through. That's also where the nervous innervation is going to be happening at. So it's all right here. And because it's right there, it's the reason why you don't have any photoreceptors. Okay, cool. So we're going to look at the last few things, the lens, the vitreous humor, and aqueous humor. So once again, I have like sort of the half assembled eye, the sclera is gone, so we're just looking at the choroid coat and everything in there. So when we take this off, when you're in the most internal part of the eye, we're going to be looking at these few things, these few structures right here. So this is your lens. This is going to be the part of your eye that focuses all your images that come through. You ciliary muscles attach to these, and you stretch them up and down to focus images. Right behind the lens is this big, kind of fluid-filled part of your eye called the vitreous humor. The vitreous humor, this is what keeps the shape of your eye, the round shape of your eye. It additionally has some nutrient components, but not really. It more so keeps shape. And then some fun cocktail biology for you. Have you ever had the experience where you've seen stars, quote unquote, like you stand up super quick and then everything's flashing? Well, what that is, that's actually the vitreous humor pressing against the retina and physically setting off those photoreceptors, making your eye think something's there, but in reality it's not. It's just being touched and it's setting off those photosensors, so it's making these flashes. That's kind of cool. And the last part of the eye, just putting everything back together here so it makes sense. So here's your complete eye. And when we put it back into the compartment with everything, the last compartment we have is here's your cornea. And the last compartment I'm going to show you is from the front of the lens, so right here behind the pupil, to the back of the cornea. So this space right here, this really small space from here to here. So from this compartment, so right back there to right up here, filling up that space is going to be your aqueous humor. Aqueous humor, again, similar job to vitreous humor, keeping the shape of the eye. So fluid from here to there. I don't know if you guys ever dissected a cow eye when you were in high school or whatever, but you remember there's just a lot of fluid coming out. That's your vitreous and aqueous humor when you dissect the eye. Kind of crazy. So now we're on to the last few sections of this lab. Part B, which is determining the blind spot. So to determine your blind spot, there's a really cool test you can do. We're going to make something like this. So if you have a note card with you, let's go ahead and take that out right now and get a pen. And this is what you're going to do. I'm just going to kind of make another one right now. On the left side of the note card, doesn't really matter. On the left side of the note card, put a little plus sign. So like that right there, like that big. Then move a few centimeters over, 6, 7, doesn't really matter. And let's put a circle right there. So your card's gonna look like this. So a little cross and a circle. Now, this test is going to work inversely proportional to what eye you use. And what I mean by that is to determine the blind spot in your right eye, you're going to look at the left object. So in this case, that's the plus sign. So what you're going to do this test is you want to cover, we're going to test for the right eye right now. So I'm going to cover my left eye. So I'm just using my right eye. And what I'm going to do is I'm going to stick the note card out in front of me like so. And I'm going to put it, like a foot and a half away from my face. And I'm going to take my right eye and just focus on that left object. In this case, it's the plus sign. And what I'm going to do is I'm going to slowly start bringing that towards me. And what I'm going to do is by looking at the plus sign, using my peripheral vision, so not what I'm directly looking at, I'm going to bring this card close enough to my face to where the circle out of my peripheral vision on the right side is no longer in view. And for me, that's about here. So that's like, I don't know, a few inches away from my face. But right now I'm just looking at the cross and that circle is totally not there. It's just filled in with white. And what we're trying to show you with this test, totally do it right now. It's super fun. It's kind of crazy. And what we're trying to show you is that your eyes are constantly filling in missing information because you have bioptic vision. You're using two eyes. Your right eye is constantly filling in for the blind spot on your left side, and your left eye is constantly filling in for the blind spot on your right side. So your eyes are just constantly doing this math. It's totally crazy. And I think with that, that's all the information I have for you today. Thank you so much for watching this video. Yeah, shoot us an email with everything else. And I think this is our last lab. So I just want to say thanks for writing this out. It's been totally weird. But I think we're all trying to figure it out. And I appreciate you guys watching these videos. I hope they're helpful. If they aren't, let us know. Obviously, having more TAs in one space to make the videos would have been a lot more fun. But because of the whole social distancing, we just have to do this by ourselves at our computers. But anywho, I just want to say thank you. Shoot me an email with any questions you have. This bird will not shut up. And I will talk to you all later. Have a great time. Bye.